All right, in this unit we've been talking about transformations, but most specifically we've been talking about rigid transformations. Rigid transformations keep two things exactly the same, and it's because it's moving the entire plane. So it keeps both the angle that you're talking about, so all the angles of your shape, it'll keep exactly the same, as well as each of the line segments, the lengths of the segments. So for example, one of the rigid transformations that we first talked about was a reflection. So when I take my shape, when I reflect it over some line, whenever I do a reflection, I reflect it over a line, it's taking every single point in this plane, and it's taking the whole plane and flipping it or reflecting it over this line that we see right here, hence creating this image that shows up on this side. This image that shows up on this side, and we're going to notate it with these primes. Although it may seem I'm only moving these corners, technically I'm moving everything in the plane and rotating it. That's why using the patty paper, we can kind of visually imagine the whole thing moving to the other side. Right? So this is a reflection, and this is the image of this shape, my original shape, which is also known as the pre-image. Right? And one of the characteristics of this is when I move stuff, okay, oops, actually, I apologize. This should be C prime and this should be B prime. When I reflect stuff, this distance from here to here, if I connect this right here, it's the same distance away from the line. And also, the distance that I'm talking about is perpendicular to that line. So it's not, doesn't show up just anywhere. I'm going to go the same perpendicular distance away. And every single point does that. Another type of transformation that we talked about is a rotation. Okay, again, rotations, no matter how I spin it around in the plane, it's still going to preserve my angle measurements as well as the lengths of each of my segments. And when I rotate, we rotate around a point. So I have to have some kind of point of reference. So if I have this as my shape, and this is my point P, kind of think about sticking your thumb here and grabbing everything up here and just spinning it right around to this side. So if this is A, B, C, this is going to get spun in this direction as A prime, B prime, C prime. Right? So again, when we rotate things around a point. Right? And again, these are all the same distances away from my point. All right, and finally, the last one that we talked about is a translation. All that does is it shifts things. It slides things to the right, slides things to the left, moves things up and down. So I might have a shape like this, and it's going to send every single point into a new position just by sliding it. And because we look at things on a grid, we can kind of think about it as moving over and down. Right? So we can go over 5 spaces, down 2 spaces. And that's what it's going to send every single point. Again, I tend to only look at the corners because it's easier to keep track of. Right? And then we end up with our shape here. So this would be B, B prime, C, and C prime. And that would be, in fact, a translation.